text form. It doesn't have the parentheses in it. Did you say you can't see? Oh, sorry. Okay. So here is standard form. Y equals ax squared plus bx plus c. So this is different than the vertex form. You can't see the vertex when you look at this. So what's going to happen here is we're going to have two little formulas. Well, it's really one little formula to find the vertex. And it's based on whatever's going to be in front of your x squared and whatever's going to be in front of your plane x. So here's what the little formula looks like. It's the negative b, so the opposite of whatever that b value is. It'll be a number when you have the actual equation, over 2 times the a value. And we're going to get into this in a second. But before you actually divide, you want to figure out what the product is of the bottom of that fraction first, and then do the division. So negative b will be just plain number by itself. Do 2 times whatever your a value is, and then divide. Once you have that, that's going to be the x-coordinate of the vertex. All you got to do once you have that, you're going to plug in whatever that number is, negative b over 2a. We're going to plug that in for x to the equation you have from the problem, and that'll give you the y value that goes with it. And that'll be the y-coordinate of the vertex. Now, axis of symmetry, still a vertical line that goes through the middle. In this form, I can't see the vertex in the equation, but I can use this little negative b over 2a fraction to figure out what that x value would be. And finally, some of the questions I've given you have been in standard form in the first couple lessons, but none of them had a term that had a plain x. Like don't write this. I maybe gave you a question like, I don't know, 2x squared plus 7 or something like that, but we didn't have anything that had a term in the middle. So the b times x, this is your linear term, and what that does is it shifts the graph off the y-axis. If you don't have that term, that little example I just did 2x squared plus 7, that just has a vertex at 0, 7, because there's nothing to shift it off the y-axis. So if you have that term in the middle, that's going to mean the vertex is somewhere else in the coordinate plane, not on the y-axis, and that's what we're going to get into today. Now, just have a little summary of what you can get from the standard form, which is not a ton, but I do want to make this note. A in standard form is the same as the vertex form. They're the same number. So if you want to figure out your pattern for how to do your graph, they're the same in both forms, so you can see it. They're going to start each of the equations. One's in front of a set of parentheses, one's just going to be in front of the x squared. So what this says right here, if a is greater than 0, so if the a value is positive is really what that means. If I'm a number bigger than 0, I got to be a positive number. That means my parabola has to open right side up. It says when a is less than 0, that just means the a value is negative. That's going to cause your graph to turn upside down. So that way you'll know immediately just from looking at the equation whether it should be right side up or upside down. In standard form, and I know I just wrote this, but I'm going to write it again to help you practice the formula. So x-coordinate of the vertex is whatever you get when you plug in negative b over 2a. The y-coordinate of the vertex, we're just going to use that number. You're going to plug in negative b over 2a for x in the equation they give you. And the final thing, in that formula you also see there's a letter c. That's the constant term. It would just be the plain number. The y-intercept is related to that. So y-intercept is just where your graph crosses the y-axis. And think about this for a second. If I'm a point and I'm right on the y-axis, what does my x value have to be? 0. So this, and I'll show you the algebra just to the side in 1 second. The x-coordinate has to be 0. The y-coordinate, if you got standard form, will always be c from that ax squared plus bx plus c. And I'm going to show you just real quick the algebra behind that. And even if I just use the variables, if you plug in 0 for x, which is what you would do anytime you're trying to find a y-intercept, you plug it into the first 2 terms, so it'd be a times 0 squared, I'm putting that in place of x, b times 0, and then plus c. Plugging that 0 in wipes out both of those first terms because you're multiplying by 0. So all I would be left with is y equals c. So anytime you have standard form, if you plug in 0, the corresponding y value will always be that constant term. It's just c in that general format. So we're going to work through how to graph these today. Is anybody having a question at the moment? Okay. Now, we all change this to a +3, right? Otherwise, it's not going to fit on the graph. Okay. So here's all you're going to do. To find, let me just ask you, what's my a value going to be if you look at that equation? I've got x squared plus 6x plus 3. What's a going to be? 1. It exists. Okay, don't put 0, right? Because if it was 0, that would be gone. There would be no x squared term. So a is 1. It exists. So automatically, I also know the pattern for the graph would just be the 1, 3, 5. The only other thing I really need is the vertex. And so we can't see that from the standard form, but we have this little tiny formula to help us figure it out. So all you're going to do is plug in the opposite of b, or negative b. In this formula, b would be the number 6. So the opposite of that would just be negative 6. On the bottom, it's 2's part of the formula, so that'll always be part of this, times the a value, which we just said was 1. So I have negative 6 over 2, which means my x-coordinate of the vertex would be negative 3. All right, once you have that, that's your x-coordinate of your vertex. So it's negative 3 something. I got to figure out what the y value is. If you know the x-coordinate, you're just going to plug it in for x to get the corresponding y value. And this is where I would grab my calculator. So I'm going to do negative 3 squared plus 6 times negative 3. And remember, we changed this to a +3, otherwise it's going to go off the graph. So I just grabbed my calculator, and I'm just doing parentheses, negative 3 squared on the outside, plus 6 times negative 3. And I just use the parentheses just right on my calculator. You can do this scientific or graphing. Simplify that, and our corresponding y value would be negative 6. So once I've got that, that's going to give me my vertex. All I have to do then, I'm just going to come over to the graph, negative 3, negative 6. All right, now, all you got to do, just the pattern like we were doing with the vertex form. So just over 1, up 1, over 1, up 3, and then over 1, up 5. If I can count. And then I'm just going to do my best to make a U shape here. It just tells you in the directions over there to just make sure you have at least 5 points. That actually has 7 different points on the graph, and it just kind of describes to you how to use the pattern, which hopefully you guys remember from doing that last week, or earlier this week too. Okay, now, maybe don't look at the graph for 1 second. The y-intercept, if I look at this, if I plug in 0 to this equation for x, what should the y-intercept be? What number? What was it? If I plug in 0 for x to that equation, what should the y value be? Why are we getting negative 6? Okay, if I plug in 0, right? Remember I told you guys at the top, if I plug in 0, 6 times 0, it's going to wipe out those first 2 terms and leave you with the constant. So if I plug in 0, the y should be 3. All right. Now, if you guys want to, I'm not on the screen, fired. Okay, sorry. If I plug in 0, wipes out those first 2 terms, you're left with the constant. It should be the 0.03. And I was just checking that. If you look over here at the graph, it just says, does that match the graph? Which I can see right there. I did go through the 0.03. So that's a good way to check to see if you graph the parabola correctly. Now, the last thing, just ask you to write this in vertex form. Forgive me, I should have written the general form for that. I'm just going to write it to the side. So that a times x minus h squared plus k. It's just going to ask you to convert it. You have every single piece of information you would need for this. The a value is the same in both forms. So since our a value was 1, usually if you would see this, I'm just going to lightly kind of put a 1 right in there, but it would just start with the parentheses. And then this is the tricky part. So your vertex was negative 3, negative 6. In vertex form, the x-coordinate is h and the y-coordinate is k. But remember, when you put it in here, it's x minus the x-coordinate, so it actually looks like the opposite of what it is. So in vertex form, this would be x plus 3. That would be squared. The y-coordinate of the vertex, you're just going to put that to the side. So that -6 just goes after you have your squared set of parentheses there. So just to show you the two different formats. Standard form's all multiplied out. Vertex forms has the parentheses in it. Does anybody have any questions? This is not terrible to do, I promise. All right, let's try. I want to definitely go through how to type this one into the calculator. Okay, what is my a value here on the back? -1. So immediately I know my pattern here, I'm going to come down and just write this, is going to be -1, -3, -5. That being negative automatically tells me that graph's going to go upside down. So we're going to go down just their pattern there, 1 through 5, but it'll be all negative. Now, I don't know the vertex. What should the y-intercept be? If I plug in 0, what should the y-intercept be? -3. It wipes out these first two terms, leaves you with -3. So when we graph this, it should go through the point 0, -3, if we did it right. I don't know the vertex, so that's really the only thing I need to figure out, and then I can use my pattern to graph it. So my vertex, opposite of b, which for this question would be -2, over 2a, which is 2 times -1. So we'd have -2 over -2, which would actually end up being +1. All right, now, when you guys plug this in, I'm just going to have you be real careful. See, that first term has a negative in front of it. So it's taking every single thing I plug in for x and multiplying it by -1. So if you want to type this in your calculator, you want to type it in like that, a little negative in front, and square whatever you're plugging in for x. It's going to be 1 for this question. So if you start out with a little negative, just don't put that in the parentheses because we don't want to cancel that negative out. It should make all those first terms negative. So I do a little negative outside, and then just in parentheses, I'm going to do 1 squared, 2 times 1, and then -3. That's just to get my y value that goes with the x value of 1, and that'll be my vertex. So we got 1 for our x value. We plug that in, got -2. That's our y value. And all you have to do, once you have the vertex and the pattern, you're good to go. Just come over to the graph. I'm going to go 1, -2. And just, this one has a pattern of -1, -3, -5. So from that point, just go over 1, down 1 on either side. Over 1, down 3. And too close to the bottom to go down 5. So this is fine though, this has got 5 points. And if you want to check your y-intercept here, it's supposed to go through 0, -3, and it definitely did, that first point I graphed after the vertex. To do the vertex form, I'm just going to copy y equals, your a value goes in front of the parentheses. For this question, you would put something because you have a negative sign, so just put a little negative. It's x minus the x-coordinate of the vertex. So it's +1. This is going to look like x minus 1. And I'm going to make sure I square those parentheses so I get my quadratic. The y-coordinate of the vertex, you just copy that outside the parentheses to get your vertex form, and that's just -2. Does anybody have a question? Okay, I'm going to have us do stretches and shrinks on the two at the bottom. So I should be able to immediately tell, does this graph turn up or down? Up. This is positive, it's 1/2, but it's +1/2. Should be kind of a little bit wider than some of the graphs we've already done today. So my pattern for this one, my a value is going to be 1/2. My pattern, if I multiply that 1/2 times the 135, remember I was telling you guys, try to write that as decimals because sometimes people like to use the fraction. The pattern here is going to be 1/2, 1.5, and then 2.5. What should the y-intercept be if you look at the equation there? 7. So we should go through the point 0.7. We'll be able to see that on the graph. And then vertex form, I don't know the vertex yet, so I can't do the vertex form or the vertex. So we got to figure that out. You can't see it from the equation. You got to do it with that little formula. So negative b here, this is negative 6 over 2 part of the formula times a. So it's 2 times a half. So if I do negative 6 on the top, what would the bottom of that fraction be? What's 2 times a half? Just 1. Those are reciprocals. So I'm going to show you this on the calculator in 1 second. So my x-coordinate should be negative 6, and I promise you that's correct. All right, let's say you were like, I just want to use the calculator. I don't want to mess around with figuring this out. I'm going to show this to you. If you just type in negative b, which would be negative 6 over 2a, so 2 times a half, I'm just going to type 0.5. If you do that and you hit equals, you're going to see on my calculator that I got negative 1.5, which is not what I got when I did that by hand. So what I want to explain to you real quick, your calculator does the order of operations. So when I type that, it reads it from left to right. So it does negative 6, divides it by 2, which would be 3, and then it multiplies that result by a half. You can fix this problem in just 1 second. All you do is you just put parentheses around the bottom of that fraction. So I'm just putting parentheses around that 2 times a half. And if you want to type it in your calculator, you can, but you have to use those parentheses because you want to take the negative b and divide it by that product. And if you put the parentheses, that'll save you from making a mistake. So if you want to use your calculator, please do, but just be real careful with that you put parentheses around the bottom or figure out what that number is before you divide. Otherwise, it'll give you a bad answer. Once you have the negative 6, I'm just going to plug it in to the original equation to get the y-coordinate of the vertex there. And if you want, I just use 0.5 instead of 1/2. When I type it in the calculator, it's less buttons to push. And just plugging this in just like I wrote it right there. And what did oh, excuse me, I forgot the negative on the 6 here. All right, so this is going to give me y-coordinate of negative 11. And I promise anything you're going to graph is going to fit on the screen with what you have today. So negative 6, negative 11 is my vertex. Now, I'm just going to scooch this up. So this is like way at the very bottom of the graph. So go 6 left, down 11. It's literally the very bottom of the graph. And our little pattern here, we had a 1/2 for an a value. So just estimate on this. Just go over 1, up a half. Just the best you can. And then over 1, up 1.5 should put you on a nice point. Should be negative 8, negative 9, and negative 4, negative 9. And then I'm just going to go one more step. Over 1, up 1, 2.5. And I'm just going to estimate the best I can that halfway mark. So something like that. To write your vertex form, I'm just going to go back. Just y equals. Write your a value right after the equal sign. It's 1/2. You can see that right from the standard form. And then my vertex was negative 6, negative 11. So it's going to be x plus 6 in the parentheses. It's the opposite of what it looks like. You're going to square that. And then the minus 11 is just going to go on the outside. I'm going to have you guys just try the last one on your own. See if you can figure out this last one. You can get a lot of information just looking at the equation. The only thing you can't see that I'm going to ask you for down here is going to be what is the vertex. So the vertex, remember, you're just going to do negative b over 2a, but you're going to make sure that you figure out what 2a is or put parentheses around it. And then whatever that value is, you're going to plug that in for x and get the corresponding y value. So go through that last question. See if you can find the vertex, find the pattern, and put that on the graph. And this one we should be able to see the y-intercept on the graph. I promise if you're doing any question on the notes or the homework, no vertex is a nasty number. So it should all be plain numbers. It could be positive or negative, but you should not have any decimals for a vertex that you have to graph. And I will give you all these formulas on any test or quiz, so you don't have to memorize them. You just need to know when you're going to use them. If you're feeling good about it, the homework should just be the next page in your homework packet. And all the graphs should fit on the graphs that are provided there. And if they don't, you maybe made a little bit of a mistake. Anybody not, the vertex should be negative 213. Anybody not getting that? If you plug in, do the negative b over 2a, it should be equal to negative 2. Forgive, I'm off the screen here. Scooch this over a little bit. When I plugged in negative 2, I got 13 for y. And then for my actual graph, and you'll see the y-intercept on this graph should cross at 0, 5, which it does. Your pattern there should be negative 6, negative 2, or negative 2, negative 6, negative 10. The negative 10, my graph doesn't go down far enough for us to do that, but that's 5 points right there, which is all you need. Is anybody having a question? It's not terrible. If you need them, you've got your notes in front of you, but I've got those formulas up on the board too, if you want to use those as a reference. Does anybody need the note paper a little bit longer?